Saxon Algebra 1, Lesson 26. We will look at more complicated equations. Often we will encounter equations that have variables on both sides. When this occurs, we will begin the solution by using the addition rule to eliminate the variable on one of the sides. It doesn't matter which side we eliminate it from, but it is very important that we pay attention to sides as opposed to parts of sides. Therefore, we will always highlight the equal sign before we begin. Here's example 1. 12 minus 2x equals x. We identify the equal sign, and we identify the left and right sides. X is on both sides. Let's see. We've got 2x on one side and x on the other side. Let's extend that equal sign, and we will add 2x to both sides. That way we get rid of the x on the left side. And we have 12 equals 3x. Now we can solve the equation by dividing both sides by 3. The 3's cancel on the right, and we're left with 4 equals x. Notice that we had 12 minus 2x on the left side, so we added positive 2x to undo the subtraction or the addition of negative 2x. Let's check the answer. We have 12 minus 2x equals x. We want to replace x with 4, so that gives us 12 minus 2 times 4 equals 4. And that's 12 minus 8 equals 4, or 4 equals 4. So our solution is correct. Here's example 1 again. 12 minus 2x equals x. We identify the equal sign. This time we will add negative x to both sides because that gets rid of the x on the right side. That leaves us with 12 minus 3x equals 0. Now we need to get rid of the 12, so we add negative 12 to both sides. That gives us negative 3x equals negative 12. We will multiply both sides by negative 1 because we don't like the negative in front of the coefficient of x. That leaves us positive 3x equals positive 12. And then we can divide by 3 to get x equals 4. I think the first method, adding 2x to both sides, was actually easier. Here's another example. 3x minus 4 equals 5x plus 7. Again, we identify the equal sign. X is on the left and on the right. We can either get rid of the 3x on the left, or we can get rid of the 5x on the right. Let's see. We'll add negative 5x to both sides. That leaves x on the left side. It gives us negative 2x minus 4 equals 7. We will add 4 to both sides. That leaves negative 2x equals 11. And we'll divide by negative 2. And that gives us x is negative 11 over 2. Notice this time we did not multiply both sides by negative 1. We could have done that, but it doesn't really matter. We're going to work this problem again. This time we're going to get rid of the 3x on the left. To do so, we add negative 3x to both sides. That leaves us negative 4 equals 2x plus 7. Now we want to get the x by itself on the right, So we will add negative 7 to both sides. That leaves us negative 11 equals 2x. We can get rid of the 2 in front of x by dividing 2. And again, we get negative 11 halves as the value of x. So we can either isolate x on the left side or on the right side. It really doesn't matter. Another example. This one's a bit longer. 3x plus 2 minus x plus 4 equals negative 5 minus x minus 4. We identify the equal sign, and we look at the left side and the right side. Both of the sides here can be simplified because we have like terms. On the left side, we have 3x and negative x. They can be added. They add to 2x. We also have, on the left side, the 2 and the 4. They add to 6. So the left side simplifies to 2x plus 6. Now look at the right side. We have two like terms there, the numeric terms, the negative 5 and the negative 4. They add to negative 9. And then we have the x that's subtracted on the right side, so we bring that down. Now that we've simplified both sides, we begin to solve the equation. We have x on both sides still. Let's get rid of the x on the right-hand side. We have negative x there, so we add positive x. We add it to both sides. That gives us 3x plus 6 on the left side and just negative 9 on the right side. Now we can begin to isolate x on the left side. It's multiplied by 3 and 6 is added. We undo the addition of 6 first by adding negative 6 to both sides. That leaves us 3x is negative 15. Now we undo the multiplication by 3 by dividing 3. And that leaves us x is negative 5. Notice that we used 4 steps. First, we simplified each side by adding like terms. Then we eliminated the variable on one side. We added x to both sides, so it wasn't on the right. Third, we eliminated the constant term on the side with the variable. That was the left side. We added negative 6 to get rid of the 6 on the left side. And then we solved for the variable. We divided both sides by 3. Another example. K plus 3 minus 4k plus 7 equals 2k minus 5. Again, we identify the equal sign so that we can pay attention to the left side and the right side. The right side can't really be simplified, but the left side has a whole bunch of like terms that can be combined. The k and negative 4k add to negative 3k. And the 3 and the 7 add to 10. So the left side becomes negative 3k plus 10 after we simplify it. And the right side, as I said, cannot be simplified, so we write it over again. Now we have k on both sides. We can either eliminate the negative 3k on the left side, or we can eliminate the positive 2k on the right side. Let's add 3k to both sides. We're getting rid of the negative 3k on the left. That leaves us 10 equals 5k minus 5. Now we can isolate the k on the right side by adding positive 5. That gives us 15 equals 5k. And we divide by 5 to get k by itself. We end up with 3 as the value of k. Example 5. Negative 7n plus 3 plus 2n equals 4n minus 5 plus n. Again, we identify the sides of the equation. We can simplify both sides here. On the left, we have the like terms negative 7n and positive 2n. They add to negative 5n. And we also have the plus 3 on the left, so we put that in. On the right, we have the like terms 4n and positive n. 4n and 1n add to 5n. And we also have minus 5 on the right-hand side. Now we can either eliminate the negative 5n on the left, or we can eliminate the positive 5n on the right. Let's eliminate the 5n on the right. We add negative 5n to both sides, and that gives us negative 10n plus 3 equals negative 5. Now the n is on the left. We will add negative 3 to both sides. That leaves us negative 10n equals negative 8. We'll multiply by negative 1 so that we have positive 10n on the left. And that gives us 10n is positive 8. Now we can get rid of the 10, divide by 10. And that leaves us n is 8/10, which reduces to 4/5. This is the end of Lesson 26. Your assignment, problem set 26, on pages 112 and 113 of your book.